Hello, I'm David and I'm the product manager of the SMEMA Hermes adapter. Today I'm going to show you some simple data validation techniques to prevent boards moving into the machine that the adapter is connected to or away from the machine downline. So I'm using Multiplug 81 and I'm using the Hermes extension 20. You can check your latest version by version number at the top right of the main user interface in modern versions. Of course, if you're watching this in the future, certain things might have changed, but the essence is will still be the same. So data validation is situations where you want to prevent malformed data, i.e. data that just has missing values or certain values, moving from upstream to the machine you're attached to or downstream, and it prevents movement essentially. Also check out the product recipe changeover videos. This is a similar situation where an external source gives the approval of the movement, whether it has to get something changed, like a conveyor width maybe has to be changed, or whether a third-party system needs to give the OK. So check out that. It's a similar kind of vein of validation verification. So I'm going to go over to the settings. I'm going to select the lane that I want to change, and you can do this for both upstream and downstream. So upstream, of course, is just data that's coming into the machine, and therefore you have really no control over it. Essentially, you haven't created it. Downstream, it might have come in from a barcode reader, it might have come in from the supervisory system, or possibly also the upstream. But so there's more likely there's going to be problems by sending downstream. This is obviously validating downstream is helping the machine downstream. The downstream machine should also do validation, but this is just another safety net. So let's do it for upstream. We'll go to upstream, we'll go to data. And as you see, we've already got two validation properties, which is the board ID and board ID created by, which actually are compulsory values. So they've already got, if they're equal, null, fail. But we're going to create a new one. We're going to say the width must be set. So it must be, if the width is equal to fail, we're going to stop. This is a no-go. And then you can use, if it does fail validation, you can not fail it and use other values. And injecting from the scan station is one such situation. So I've changed that. Let's go back to the user interface. Let's send the board down without a width, and it's failed. The PCB validation has failed, and the reason is the width equals null or empty, and it's simply as that. I mean, in that situation, you can't really tell the upstream to do anything, to revoke it. So at that point you would have to go up to the upstream machine and revoke it manually, or you can kind of force it by restarting the connection, and therefore but it's a very it's a no-go situation essentially. There is no way of automatically resolving the situation. You have to understand why it hasn't sent the values. But I can revoke the board, and obviously it clears it back down, and I can do the same with the downstream. So if, as I said before, if a data was created on this machine, it would stop going down line. So that's all I have to show today. I hope it's useful, and thank you for watching.